In this video, we're going to learn how to solve problems involving application of differentiation. For JAMB Maths, we're going to practice with 2 repeated questions for this topic. So let's get started with the first one I have here. It says, obtain a maximum value of the function f of x equals this expression. Alright, now note that in mathematics or calculus, f of x is the same thing as y. So let's replace f of x with y for this question. This will be the function y equals s cubed minus 12x plus 11. Alright, now note that when you want to determine the maximum value of a function, you are going to make use of what we call second derivative test. Alright, so before we get to that point, let's find the critical values for this function. So at critical point f prime of x equals 0. So let's find the derivative of this function. It will give us, when you find the derivative of this function, it will give you 3x squared, alright, minus 12 equals 0. We make x the subject formula. So when you do this, it will give us 3x squared equals this minus 12 equals over the equality sign, change to plus, equals 12. So divide both sides by 3. So we have x squared equals 4. You square root both sides. So our x will be plus or negative 2. Alright, so we have 2 values of x now. X equals 2 and negative 2 as the critical point of x. Now, we have gotten the critical point of x to be this value. Let's now apply second derivative test. That's how you can determine the maximum value or minimum value of a function. Now, at second derivative test, a function is said to be maximum when is less than 0, whereas a function is said to be at minimum when f double prime of x is greater than 0. Okay, so using second derivative test, the function is said to be maximum when is less than 0, whereas it's said to be minimum when is greater than 0. Alright, just opposites of each other. Now let's get the second derivative of this function. Remember, we have the first derivative to be this. Okay, so to find the second derivative, differentiate once more. When you differentiate, you're going to have 6x. That's basically what you're going to have when you differentiate once more. Alright, so now let's impute the values of this critical point respectively in this output for the second derivative and see the one that will give us less than 0 and greater than 0 to determine the maximum and minimum value. So when x is 2, when you plug in 2 here, you're going to have 12 as output, whereas when x is negative 2, when you plug in negative 2 here in 6x, you're going to have minus 12. So at negative 2 for the second derivative test, when you simplify the output, you're going to have negative 12. So this shows us that at the critical point of negative 2, we're having an output of negative 12, which shows that it's less than 0. Okay, is at maximum, whereas when the value of x is 2 at the critical point, when you plug in here in second derivative test, you're having an output of 12, which is the minimum. Now that we have recognized the maximum point, which is negative 2. Okay, now the question says obtain a maximum value of the function f of x equals x cubed minus 12x plus 11. Now To get your final result, now I've gotten the point of maximum, which is -2. What you now do is will be to take this -2, that is the point of maximum, and substitute it in the original function to get the final result. Alright, so when you plug in -2 in the original function, this will give us -2 cubed, okay, minus 12 times -2, okay, plus 11. When you break down, -2 cubed will give you -8. Okay, then we have minus times minus give a plus, so we have -8 plus 24 plus 11. So when you punch this the calculator, you are going to have -8 plus 24 will give you 16. 16 plus 11 will give you 27. Alright, so that will be the final result for this question. The correct option is option B, 27, and not -2. Alright, so that's it for this question. Now, had it been the question is asking about minimum value, what you would have done is this, because at the point of 2, we're having 12 as the output is greater than 0, so it's a minimum value. What you would have done is to plug in the value of 2 instead of -2 in the original function. Whatever it gives you as output will give you the minimum value. Alright, but for this question they asked about maximum value, not minimum value. So the maximum value of the function is 27. So that's it for this question. Let's wipe this now and solve the last repeated question I have for this video. Alright, so the last repeated question we're going to solve will be this question. It says, for which value of x is the tangent of the curve y equals this function parallel to the x-axis. Okay, now note that a tangent to a curve is said to be parallel to the x-axis when the slope of the function equals 0. So basically this function, we have y equals x squared minus 4x plus 3. We're going to equate it to 0. Alright, so when you want to find the slope of a function, basically you find the first derivative, that will give you the slope of the function. So this will give us, when you differentiate this, you're going to have 2x minus 4 equals 0. Make x such a formula, so x will be 2x rather will be this minus 4 equals to by 24. So you divide both sides by 2. So our x will be what? 2. And that will be the answer to this question. So in application, what it implies is that at the point x equals 2, the tangent of the curve is parallel to the x-axis. So the correct option is option C, that's 2. It's as simple as this. This basically you can deal with these kind of problems under application of differentiation or derivative for your JAMB Maths. Hope you learned something interesting from the video. Let's call it a video here. If you are new to our channel, ensure that you are subscribed to this channel for more of our videos. Also like, share, and comment on this video. Let me know how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave your question at the comment section below, and I'll be sure to give you a response. Alright, now click on the end screen above and I'll see you in the next video. Thanks for watching.